One of my students keeps pasting wallet addresses into a block explorer trying to piece together what did this address actually do. Swaps, NFT buys, incoming payments, and gives up halfway through page 3 of results. They want a simple lookup tool. Paste an address, get back a clean, complete history of everything it sent and received. This is a pagination correctness problem varying a UI convenience costing. The hard part is never stopping early, not the formatting. So these are the 8 steps which are required in order to get hold of all the transfers that have been performed by a given wallet address. As per the problem statement, we are given an address as input. First, we need to validate the address. After validating the address, then we make an API call. And this API call is made via the function getAssetTransfers, which internally calls Alchemy's transfer API. GetAssetTransfers accept the from address, and also it accepts the conditions which includes multi-category with metadata, and we set excludeZeroValue to false in order to capture zero value NFT transfers. After that, getAssetTransfers will keep on calling as long as there exists a pageKey. So it will re-request until a response has no pageKey left. Step 4. So step 4 is repeating step 2 and step 3 as long as pageKey exists. At step 5, we merge both directions, fully drain results. When we say merge both directions, so it includes the transfers where the address is the sender and also the transfers where the address is the receiver. At step 6, we perform the deduplication by taking hold of the uniqueId. And at step 7, we sort both the transfer directions result into one consistent chronological order by using mergeAndSort. And at last, we give back the result in a human readable direction tagged feed with timestamps including zero value NFTs. So these are the 8 steps required in order to get hold of the entire wallet asset transfer history. First, we are going to look at the cli.ts file. This is our entry point in order to capture wallet asset transfer history. Have a look at the CLI arguments interface. It has 4 members. First is address, network, order. Order can be either ascending or descending, and then JSON. If you pass JSON equal to true, the result will be printed in a JSON format. After that, we have this pass argument function. What it does, whatever the command line arguments we pass in order to get the wallet asset transfer history, those arguments are being parsed by this function. This is our main function. Initially, when we invoke our CLI, it will call pass arguments, and that arguments will be captured into this args const variable. Once we have the CLI arguments, then the first thing we do is we validate the address before making any network call. So this is our validate address function, which is invoked with the arguments args.address. If the address is valid, then it will return an address or it will throw an error. After that, we load the config for the given network. Then we call fetchAllTransfers. The raw transfers are being returned by fetchAllTransfers. Those transfers are then merged and sorted. At last, if we are passing the JSON command line argument to be true, the result will be printed into a JSON format or the result will be printed into human readable format. Let us now have a look at what exactly fetchAllTransfers does. We are into our Alchemy client code. Inside Alchemy client, we have this fetchAllTransfer. Notice this function is making a call via promise.all, which ensures that drainTransfers, this function will be called parallel. First, using the from address, and second, using the to address. Why exactly are we passing from address and to address? We are going to find that out sooner. And at last, whatever the result is returned by drainTransfers into outgoing and incoming, it adds those results into an array and returns that result. So basically, fetchAllTransfer will return all the transfers where the user is the sender or the transfers where the user is the receiver. Let us now go ahead and have a look at drainTransfers. So here we have direction parameter can be either of from address or to address. If you look at from line number 75 to line number 90, it is a do while loop. Now inside this do while loop, what we do, first we create the params object. In the params object, we specify the from block, to block, and category. So these categories are external, internal, ERC20, ERC721 and ERC1155. The problem statement clearly specifies that we should fetch all the transfers based on these categories. Hence, we are specifying those categories explicitly. After that, we are setting withMetadata to be true. This is required to get metadata.block timestamp because block timestamp is being returned only when we set withMetadata equal to true. And going ahead, we set excludeZeroValue to false. This ensures that we are not silently dropping zero value NFT transfers. After that, we set the max count. Here max count hex is nothing but 1000. And here, if you notice, direction param. This is how you specify a dynamic key value pair. Here, when we pass from address, in that case, all the transfers will be fetched where the user is the sender. And when we pass direction param equal to toAddress, in that case, all the transfers will be fetched where the user is the receiver. Once we have constructed this params object, then we make an Alchemy RPC call, passing in the config and the params. Once the results are back, we push all the raw transfers into the results array. So here we have results. It is of type Alchemy transfer. And at last, we set the page key, and this do while loop will go on executing as long as the page key is not null. So if at all an address has performed 1 million transfers, as long as 1 million transfers are not exhausted, this do while loop will keep on fetching the transfers for the given wallet address. This is how we are fetching all the transfers, wherein the address can be in the from address or the address can be in the to address. What exactly is RPC call? We are making a post call wherein internally we are calling the method alchemy underscore get asset transfers and the params which we have constructed in the drainTransfers function. After calling fetchAllTransfers, we invoke mergeAndSort and pass in the result returned by fetchAllTransfer. Remember, fetchAllTransfer returns Alchemy asset transfers. Now this Alchemy asset transfers is being defined or declared inside types.ts. This is Alchemy asset transfer interface. These are the key values which the raw transfers will have. Once we get hold of all the raw transfers, then we call mergeAndSort. Let us go and check what exactly mergeAndSort is doing. First of all, it performs deduplication by uniqueId. Passing in the transfers, running a map on these transfers, we tag the direction and then we pass in the individual transfer and the queried address. Deduplication will remove all the duplicate transfers. Once that is done, then on the distinct transfers, we run a sort. And then depending upon the order, we return the transfers which has been fetched from Alchemy Transfers API. If we check the deduplication by uniqueId function, what it does, first it creates a map, then it will run a loop on all the transfers. It will check if the map has the given uniqueId. In that case, it will not set that uniqueId into the map. If the map does not have a uniqueId, then it will set that uniqueId for that transfer object into the scene map. And at last, it will return all the values of the map. When deduplication by uniqueId is called, it is called with all the transfers, and those transfers can contain duplicate values. But it returns only those values which are non-duplicate. And at last we perform the sorting on the non-duplicate values, and depending upon the order, either ascending or descending, we return the result. Last step is if the user has performed or passed the args.json to be true. In that case, we print the result into a JSON format, else we print the result into a human readable format. So this is all when it comes to the exact implementation of a CLI in order to get wallet asset transfer history using Alchemy Transfers API. This is how you can invoke the CLI by using npm start, and these are the command line options: -address, -network. Network can be either of ETH mainnet, Polygon mainnet, Base mainnet, Arbitrum mainnet, or Optimism mainnet. And this is where you perform the order. It can be either ascending or descending. This is a flag if you want the result to be printed into a JSON format. Network takes in for which network you are trying to fetch transfers. Order decides whether to return the result either in ascending or descending order. JSON decides whether the result will be printed into a JSON format or human readable format. This is an example of invoking the CLI npm start --. We pass in the address. Now this address belongs to vitalik.eth. It is a busy address with tens of thousands of transfers across ETH, dozens of ERC20s and NFTs. So the tool has to fully drain pagination in both directions across every category to report it correctly. In the next step, we are going to run the test first, and then we will run our CLI against Vitalik's address. Let us now go ahead and run the test cases first. npm test. When we run npm test, you can see we have written 8 unit test cases, and these 8 unit test cases are being specified explicitly in the problem statement that these 8 test cases must pass. So we have ensured that whatever has been specified in the problem statement is being taken into consideration, and our CLI does work as expected. Now after this, let us run the actual CLI. npm start --, and go and paste Vitalik's address. We copy this, going back to terminal, print. Since Vitalik's address has a lot of transfers, so this will take time. Or what we can do, we can go to Etherscan, fetch an address which has 20 or 40 ERC20 tokens, and we'll try to run our wallet asset transfer history fetch CLI on that address. We are going to run our wallet asset transfer history CLI against this address because this address has a limited number of tokens. Given that, we are assuming that it can made few transfers. Let me copy this address, go back to terminal. Here, remove Vitalik's address, paste the new address and run. As you can see, it has printed down all the transfers which has been made by this wallet address. Now, if I want this transfers to be printed in JSON format, I'll have to specify JSON too. Okay, it says PM start. In order to print the result in JSON format, we have to pass in the flag --JSON. So here it is. It has printed the result in JSON format. And as we have set withMetadata equal to true, hence inside withMetadata, we are getting block timestamp. We are also tagging the direction, whether it is received or sent. Thus, we can conclude that the wallet asset transfer history CLI is working as expected.